Okay, we can convert from grams to moles to a number of atoms. To convert from grams to moles, you would have to divide by the molar mass. To convert from moles to number of atoms, you would have to multiply by Avogadro's number, which is 6.02 times 10 to the 23rd. Okay? And of course, that's going the way that I have the arrows drawn. If you were going from number of atoms to moles, you would divide by Avogadro's number. If you were going from moles to grams, you would multiply by the molar mass. Okay, so going forwards is what I've written in black and backwards is what I've written in red. You can also convert straight from grams to number of atoms, but that's going to take into account both of these numbers, both molar mass and Avogadro's number. If you're converting straight from grams to number of atoms, you are going to need to multiply by Avogadro's number and at the same time dividing it by the molar mass. And of course, if you were coming from atoms to grams, you're going to have to multiply by molar mass and divide by Avogadro's number. And there's a little flow chart like this in your book that might be helpful as well. But the two problems I've been asked about to explain, first this one, how many moles of cobalt atoms are in 6 billion cobalt atoms? So we're going from how many moles of atoms, that's what we want to know, are in 6 billion atoms. So since we have to go this direction, looks like we're going to need to divide by Avogadro's number. So let's set that up. We are given 6 times 10 to the 9 cobalt atoms. The units we need to cancel are atoms, because that's what we're starting with. We want these to cancel. We want our answer in moles. And a mole of anything is 6.02 times 10 to the 23rd of those things. Let me punch this in our calculator. And we will get 9.97 times 10 to the minus 15 moles of cobalt atoms. Now, something I want to point out here that a lot of times I see students mess up on is entering this in their calculator. When you enter this number in your calculator, there's two different ways you can do it. You can enter 6.02, just the decimals, and then the times key. Then some people will enter 10, and then they'll hit the little, I call it the rooftop key, 23rd, okay? If you are entering the number like that, you have got to put that number in parentheses. Because if you don't, then mathematically your calculator is doing what you're saying. You're entering it wrong. Because the calculator is going to divide by the 6.02, but then it's going to change its function here, and it's going to multiply by 10 to the 23rd. And so I hear students say often, the calculator gave me the wrong answer. No, it didn't. It gave you exactly what you were asking for, which is to divide by the 6.02 and then multiply by the exponent. Okay? So I said there's two ways to enter it. The other way to enter this number would be to punch in when you enter scientific notation, and that goes for this number and Avogadro's number, is to enter 6.02, and then somewhere on your calculator there's an EXP button. Sometimes that's an EE. On the TI calculators, the EE, if you look right above the 7 key, there's a little apostrophe, and there's an EE, so you have to do the second key to get the EE. But you could enter it like this and then do the 23rd. So what the EXP or the EE are doing, they are taking care of this times 10 rooftop. If you are going to use this method for entering the number in scientific notation, you don't have to worry about those parentheses. Okay? So let's look at the other problem that I was asked about. In this problem, you're starting with grams and asked for atoms. So if we look at that flow chart we did earlier, we have two choices. We can start with grams and work all the way around here to get atoms, or we can start with grams and work here to get atoms. Either way. So I'm going to start with 25.85 grams of copper. And if I set it up that I want grams of copper to cancel and I want atoms on the top, here I'm going to need a molar mass. So I go to my periodic table and I see that the molar mass of copper is 63.55 grams of copper. Well, when I have that much copper, how many atoms of copper do I have? Well, it's a mole of copper, but that means it's 6.02 times 10 to the 23rd atoms. And it's copper because that's what we're asking about. So I say 25.85 times 6.02. I'm going to do the EE key on my calculator. But you could do the times 10 rooftop if you want to. It's just a good idea anytime you're doing that is to always enter that number in parentheses, the whole scientific notation number. And I end up with 2.45. Really, I need 4 sig figs in this, so let's do 2.449 times 10 to the 23rd copper atoms. Okay, and that will explain those two questions.